Hello everyone, I am Mohammad Mahfouz Alam and teaching chemistry at Ramanujan School of Sciences from last 5 years, and I am one of the co-founder of the Ramanujan School of Sciences. So in previous video we have learned about the atomic mass unit, or you can say the particle mass unit actually roughly. So we learn about that. So today we are going to use that particular derivation. The particles. I am Mahfouz Alam and teaching chemistry at Ramanujan School of Sciences from last 5 years, and I am one of the co-founder of School of Sciences. So in previous video we have learned about atomic mass unit, or you can say the particle mass unit actually roughly. So we learn about that. So today we are going to use that particular derivation and those concepts to start the new chapter or a new topic you can say that the mole concept. Okay, so before going into the mole concept, let me tell you about the different types of the particles. Why it is very important? Because many times you will have the confusion while knowing about the particle itself, right? You will get confused about the particles. So let's talk about the particle first. Okay, so types of particles, right? So as I told you, there will be atomic particles, the particles who will be the atoms, okay? And then you have the molecular particles, and then ions, right? These three types of the particles we'll be generally discussing about in whole chemistry, you can say. So here the atomic particles, right? So atomic particles means what? The substance whose particles will be atoms. What the meaning of it? Like suppose every substance, you know, right? You may have studied in your 10th standard, 9th standard that every substance is composed of what? The particles, right? Now here for each substance, what different types of particles? So there will be three different types of particles only, right? So atomic particles, which type of substance have the atomic particles, right? So let me tell you here, like the helium or neon, those gases, those substance will have particle as what we can say the atomic particles, right? So example I'll give you here. ETC, right? Now let's talk about the molecular particles, right? So molecular particles. So what is the molecular particles, right? You may have heard like definition will be like what? The molecules are made of what? Two or more different atoms, right? But that's not true, 100%, right? I'll tell you through the example. First, let me explain you what the molecules. So you can say this way: molecules is a particles which is composed of the atom of either same element or atoms of two or more atoms of different elements. So this is the key point here. The same element also, like same element atoms, if it is composed of two or more atoms of the same element, then also we can say the molecules. It is not necessary that it should be from the two different elements, right? So this is the key point here. So let me tell you some examples. So here example will be for hydrogen, H2. So for hydrogen gas, remember hydrogen gas, the particle of it is not hydrogen atom, that will be H2. Now for water, particle will be H2O, right? So what is molecule exactly? See, the one part you may have seen in the books and all, right? Like the molecules is a combination of what? Atoms, two or more atoms of either same element or two or more atoms of the different elements. This is true, but this is not 100% true actually, this definition. One more condition is there, like it must exist freely in nature. If this condition is not true, then it's not a molecule. So here I am marking this one as a star. Note down this one. It must exist freely in nature. So for hydrogen gas, H atom does not exist freely in nature. H2, the HH combination, right? H2 exist in freely in nature. So that's what the particle of hydrogen gas will be H2. For water, it's not hydrogen and oxygen atom separately. It's what? Combination. In what proportion? That is also fixed, right? H2O proportion, right? Now let's talk about the ions. So these particles, where this particle exists actually, right? Ions means, right, some of the particles which have the charge actually. You can say the charge, whether negative charge or positive charge, doesn't matter, but it should be having the charge. So this type of particle exists generally in where? The ionic, you can say the ionic compound, which we're going to learn further actually in general chemistry, in organic chemistry, or maybe in this one you will be learning about it. So ionic compound. In that one, the particles will be what? The ions. This example, one example I'll give you here, the salt actually. So the normal salt. You will be writing, right, normal salt as a like their formula unit, or we can say chemical formula NaCl, right? But this one is composed of what? Here the particle is Na plus and Cl minus. So you see here the particle will be Na and Ca minus. Na plus means positive ion, sodium positive ion, and the chloride negative ions will be what? That the particles here, right? So now here you know the different types of particles, right? Now it's easy, right? Why I was talking about all the time with particles, I was not talking about the molecules or something, right? Because the many times you will see the molecular weight or molar mass means what? Molecular mass or something. So that means they're talking, most of the time you are talking about the molecules actually. In many examples you will be seeing it there. But be careful, you always talk in terms of the particles. When they talk about the molecular something, then it's related to the molecular types of the particles. When they're talking about atomic thing something, then it's talking is type of what? Atomic particles. Okay. So okay guys, so this that's it, the different types of particles. Yeah, so now we are going to define different types of the weights, right? We learned about terms, so we'll go fast actually, and we'll try to go ahead. So here the molecular weight. Again guys, mass of, we'll try to write down the we'll try to write it short. Okay, so mass of a molecule, simple. But keep in mind, molecular weight means mass of one molecules. Now you have so here we are talking about ionic weight. So what it means, like mass of one ion. So here that will not talk much about it, but it's very important. You need to keep in mind that mass of one atom only, one thing only we are discussing here actually. Now one more thing comes, formula unit. What is the formula unit? See, so formula unit is for this one, I mean to say the ionic compound, because there the particle is ions, right? Na plus and Cl minus. So you need to like see that you cannot say the Na. So here we'll be talking about in terms of the ratio of number of atoms of positive and ratio of the negative number of what you can say, the atoms of ions of the negative ions, actually all ions, right? Proportion we'll be talking about actually. So this will denote you what? The formula unit. Okay, so formula unit mass we are talking about here, right? So this is the three things we discussed now. Now let's talk about that mole, right? Because now we discussed the fundamentals. Now we're going to talk about the mole actually, right? So let's talk about the mole. What is the mole actually, guys? So mole is nothing but a number actually. We are telling you mole is number. Like it's similar to the dozen. Like, or maybe we can say that century, right? 1 century means what? 100, right? Something like that. So here 1 mole of something equals to 6.022 10 to the power 23 of number of atoms. So what is the key point here, guys? 1 mole here. This is the key point here, and this thing actually. And what is repeating here? This guy, right? So here, guys, this we need to keep in mind, guys. 1 mole means what? The number. 1 doesn't means 12. The 1 mole means Avogadro number. That is 6.022 into 10 to the power 23, right? So now one more definition we are going to you may have studied in your textbook. That definition and this particular definition both are the same, both denote the same thing, but the language, the other definition is in language format. Let's prove that one, and then we can go ahead and we'll try to see the relationship between these two. Okay, so mole. So the mole is what? The number of atoms present in 12 gram of C12 isotope of the carbon. That's the standard definition, right? So present in 12 gram of C12 isotopes, right? So let's see, like this one and these two are the same, right? These two are the same. We need to prove that, right? Because this definition you may have seen many places, but we need to visualize it. Now here, everything we are going to do through the little bit mathematics, guys. Logically, we are going to do everything logically. So whole aim of us is what? Go through logical way actually, right? Because you may have seen in chemistry, you may like remembering and memorizing it, and you are solving the question. You will be able to solve also, but that is not the goal here. So this will be completely different way of learning the chemistry. Okay, so let me erase some part of it. You note down it. Okay. Okay, guys. So let's prove it. Okay. So mass of one C12 atom, you know already 1 point. This one you know, right? Now they're talking about the number of atoms present in 12 gram of the C12 isotopes, right? So total mass is what? They're talking, they gave you 12 grams, right? In that one, how many number of atoms present? That will be the mole definition, right? So number of atoms present in 12 gram of C12. Okay, so 12 gram divided by this is a total weight. They are telling you to identify number of atoms in 12 grams, right? So simple here, right? 1 point. Right. This is also in grams. What are you going to find out? 6.022 roughly, approximately 10 to the power 22. So this again, this is the mole definition, right? 1 mole definition, right? From here you can say this is the mole definition, right? Not 1 mole is defined as the number of atoms present in 12 gram of C12 isotopes, right? So this is the mole definition. Now here you can put, oh, it's the same thing. So both are the same right now. Now this is the basic definition. Both definitions are equivalent. That we proved it. Now let's go ahead and try to find out the relationship, right? Different ways how to calculate the moles, right? If they are telling you calculate the moles when the mass of substance is given, or they tell you calculate the number of moles of substance when the number of particles is given. So there will be two different ways actually. So let's prove that, and then okay, so that will be the end of this particular mole concept chapter, because we are going to give you small things actually, unique things actually, how to prove and how to learn through mathematics or logically. That's what the goal is here. Okay, so let's go ahead and we'll try to find out the relationship, right? So before that, we'll tell you some definition again. That definition is what? Very basic actually. So that you need to keep in mind all the times. Like that definition is very, very important actually. So let's go ahead. So here we are talking about guys the molar something. So molar molecular mass, molar atomic mass, or molar ionic mass. So molar means everywhere the molar concept is same. Molar means 1 mole of mass of 1 mole of something, right? Whether particle can be molecules, ions, or maybe the atoms, guys, right? So that depends upon us, right? So anyway, let's go ahead. So molar molecular mass. So generally this is denoted by M, guys, and that we can say, guys, molar molecular mass. This is for molecules. Okay. Now the molar ionic mass. Ionic mass for ions, right? And then molar atomic mass. Atomic mass for atoms, for 1 mole of atoms, right? So molar ionic mass for 1 mole of what? Ions, guys, here. And then molar molecular mass means what? Mass for 1 molar molecules. Right, so this is the basic definition, guys, right now. So here the interesting thing you will come to know, whatever the molecular weight means, for particle weight were there and the molar weight is there, both will be same in value, but unit will be different. In case of the particle weight means what? Atomic weight, molecular weight, or ionic weight, the unit were mu. Now here the unit will be what? The value will be remains the same actually, and then the unit will be different here in grams actually. So this is the key point here. Now, so this is the key point here. Now see why I am telling this one, because this is the one you'll use many places, and sometimes there many big confusion will arise here actually. So let's go ahead and try to prove. This is a very easy, but let's try to prove it. Okay, so let's go ahead. See, we need to find out this relationship, right? We can say the molar mass. Any particles means what? It will change, but particle may be molecules, maybe ions, or maybe atoms, but the concept remains the same. I mean, so the value remains the same actually, guys. So the molar mass of particles will be equals to the value of it. The value means, and yeah. So molar mass of the particles will be equals to that particle mass. Okay, but here the value I'm talking about, the particle mass unit were u, right? But the value remains the same. Both the value will be the same here. The particle mass, you know, the unit will be u, mu, and then it will be like the value of molar mass will be what? The in grams, right? So let's prove that actually. So let's see how come. So let's see. M is the, let's say like the M is the molecular weight of one particle, one molecule, right? So anyway, molecular weight means what? The weight of one molecule itself, right? This will be in what? The unit will be in U, guys, right? Means mu. Unit will be in mu. Now let's prove that molar mass of molecules will be m grams, right? So this is the one key point here. Guys. So, and you can do the same thing for atomic thing, and then atom particles, and you can do for the ionic particles also, right? So let's go ahead. So molar mass here, molar mass of 1 mole of molecules, right? So it means molar mass of molecules means what? Mass of 1 mole of the molecules, right? Now here, so we can say in 1 mole, how many particles will be there? How many molecules? That will be 6.022 into 10 to the power 23 molecules, right? Not. Now here, so if you know the mass of 1 molecules and you know the how many molecule is there, then you can get the total mass, right, for 1 mole, right? Not. So let's go ahead and calculate it. So you can say 6.022 into 10 to the power 23 into now mass of the 1 molecules, which you told what? Mu. Mu means what? In atomic mass unit, right? So Mu. So you told Mu. Okay. Now guys, Mu. Now you see guys, this U value also you know, right? U value you know 1.66 into 10 to the power minus 24 gram, right? That you know, if you replace it, you will get the value in grams actually, right? So when we are going to M into 1.66 10 to the power 24 gram, that means M gram. So here you came to know that both are equal actually, right? We are able to prove it, both are equal. So you can note down. Then last topic, last part of it, this mole concept, we'll try to derive it, the relationship between the molar mass and Avogadro number and number of particles. So that will be the last part of this topic. Okay, so you can note down this one by pausing the videos. Okay, so let's go ahead further now. Okay guys, so now this relationship we are going to prove it, and NP, let me write it clearly actually, so NP divided by Na equals to M by, let me explain the term here. NP stands for number of particles. So particles anyway you know, we don't going to repeat, it means atom, ion and molecules, right? So NP stands for particles. Na Avogadro number, and M is the mass of substance, and M is the molar mass. So molar mass of molar mass, right? So this data is given. Now let's prove this one, right? So we know that, again we'll go through the definition of it, right? M stands for what? Mass of the 1 mole of particles, right? So here we'll try to go ahead. Okay, so see, so you can say here the number of particles, right? How many particles in given mass of this one, right? So M by M they gave you right here. So let's see, anyway we can start now. Okay, so I'm telling M grams, here M is the molar mass, right? So M gram of the substance equivalent contents means what? Is give you what? How much? M gram of substance give you how many particles? 1 mole particles. So 6.022 into 10 to the power 23 particles, right? 10 to the power 23 particles they gave you. Now in 1 gram. 1 gram how much? 6.022 into 10 to the power 23 divided by M. This many particles, right? Now in M grams. So 6.022 into 10 to the power 23 by M into M. This many particles, right? Right, so this is in M grams, sample contains M gram, that is means this many particles, right? And we already know this many particles what? We are telling NP, right? So we can equate now, right? Both. So we can write down here NP equals to, NP means what? Just nothing but number of particles, right? So we can say M by M into this number is nothing but Na, right? This number is nothing but Na, right? This we can write down, right? So we are able to write down this one. When you rearrange it, what you find is the same as this one, right? Not. When you're going to rearrange it, it will be same as this one, right? So we are able to now prove it, right? So you can note down, then we'll go ahead and define the mole definition again, okay? Okay guys, so now we are able to get this thing. Now we can say this is the what? These two are the number of moles itself, right? Let's prove it. That means what? We are done actually, right? So let's go ahead. See what is the number of moles? M denotes the number of moles here. Number of moles. So we are telling these two ratios, what were there? That is the number of moles, right? So N will be equals to NP by Na equals to M by M. This is the what our goal is, right? This is our goal actually. Now, so this is our goal. We already proved this is equal. Now we can say this two value ratio into it. This will be the number of moles itself, right? So you can say that see 1 mole in a particles will be like Na particles. We can say Na particle. What number of particles means what? 1 mole of the substance. So we can say it's a 1 mole of particles, right? We can say this one, right? Here Na particles, we can say 1 mole of the particles, right? Then 1 particle is equivalent to how many moles? We can say 1 by Na. Right? This simple multiplication, right? 1 by Na, right? In N particles, NP particles, how many moles? Right, that's the goal actually. So NP particles, it will be NP by Na, right? This many moles actually. So we know in the sample how many particles it contains? NP particles, right? So this is the number of moles, right? So we can say N equal to NP by Na, right? So this is we are able to derive it now. So NP by Na, and from here we know NP by Na equals to what? M by N. Now this is the two formulas we'll be using in calculating, right, number of moles. Many places actually, right? So we are able to derive this one, guys. This will be very helpful actually. This is the very basic. I'm not saying this is the very, I mean, say advanced one, but it's very basic. But it's needed actually, because to go further, to go in next video in means higher level, little bit higher level, or we can say advanced level, then you must know these basics. This is the must. Okay. So thank you guys for watching the videos, and hopefully the next times and or next video will be like we'll go ahead and use more mathematics actually, and we'll give you some interesting like proof and all, right now the basic you already know. So thank you guys, kindly subscribe, like and comment it here.